Hello, my name is Antonio Famiglietti. I'm a researcher at Universidad Politécnica de Madrid, and I'm going to present here a work on community solar cooker using linear Fresnel collector. As we know, nowadays there are all around the world several examples of solar cookers. There are several projects using very nice device for cooking food using solar energy. We can distinguish here at least two categories of solar cookers. We have individual or family size example used for cooking a few meals for a few people. But also we have a larger project where solar energy is used directly to cook for community scale application. So in the first category, we find a large variety of concept using different techniques for cooking. For example, using concentration of solar energy, using mirrors, using the reflecting surface. So we have very different application. But we have also non-concentrating device, which are in general more simple. But in looking at community size solar cooker, we have maybe less example, because in general terms, building and running community scale solar cookers is a bit more difficult because they require more sophisticated system. In general terms, they can be more costly, but in any case, we can find a very nice project all around the world using, for example, Scheffler type concentrators, which are able to focus the sunlight on a fixed point where the cooking object, the cooking element is located. Or we have, for example, the Lightfire project, which is a very nice project using concentrator, a very nice concentrator for cooking. We can say that the example we find, they use the direct use of sunlight, because they are able to concentrate the sunlight thanks to a concentrator directly on the cooking point, on the cooking element, for example, a pot, a oven, where the food is located. So these systems are in general, let's say, simple, because they have very low number of pieces, and they can be operated easily. Another possibility would be to implement an indirect system where solar energy is concentrated and then is absorbed by a liquid, a fluid in general, which flow inside a circuit, and it is able to deliver heat to the cooking element. So in general terms, this concept can have some advantages, because the cooking point can be located inside the building, so we can have interior cooking, which is more comfortable maybe in some context. The cooking point is not directly related to the position of the concentrators, but of course we increase the complexity of the system, because we add elements, we have a fluid, a liquid, which need a hydraulic circuit with hydraulic elements like pumps, etc. So in general terms, this concept is not used, but here we propose a simplification for implement such concept. First, let's say that the type of concentrator we use in this project is different from the others on the used on other projects, and is a linear Fresnelcollector. Linear Fresnelcollector is a very nice concentrator, which is used nowadays in concentrated solar thermal plants, but also for industrial application for producing heat. So Fresnelcollector have very nice feature. For example, it has a segmented primary reflector, where a certain number of mirrors rotate very close to the ground, So in general terms, they don't need complex system for tracking the sun. So they can be, the mirrors can be moved by very simple mechanisms consuming negligible power. And they have, sometimes they have in some application, secondary optics, which is able to increase the optical efficiency of the system. And in the focal line of the reflector, we have a special tube, which is an evacuated tube receiver, which is designed and manufactured for solar thermal power plants. It's a special element which use a special coating for reducing the thermal losses by radiance to the ambient, and they use the vacuum inside the evacuated tube in order to reduce the convection losses. So in general terms, is an object able to reduce the losses to ambient. It has a very high efficiency, thermal efficiency. So these systems are nowadays used, as I said, for producing heat for industrial application or for producing electricity. But in this context, we want to use a linear Fresnel collector for cooking. So for this application, we consider the possibility to apply commercial system, which are already manufactured and sold on the market, and they are very mature technology and reliable technology. So the current practice in thermal engineering is to use a linear Fresnel collector with a specific heat transfer fluid to collect heat from the receiver and bring to the point of usage. This heat transfer fluid is in the state of art is a liquid, generally is water or thermal oil, etc. But in a recent research at Carlos III University of Madrid, we demonstrated as it is possible to use to avoid the use of a liquid and to use directly air. So we demonstrated running a prototype, a real prototype, how we can use air as heat transfer fluid. So we can heat directly air in a linear Fresnel collector for different applications. The project TurboSol was focused on providing hot air for industrial application up to 500 degrees. And here we propose to scale the concept to solar cooking. So the concept can be applied as follow. We can use a linear Fresnel collector with a fan or blower, which is able to blow air from the ambient directly inside the receiver tubes. So air gets heated by solar energy up the desired temperature, and then can be sent, for example, to an oven, or can be sent directly to a cascade of pots where we locate the food, or it can be sent, for example, to a dryer. Maybe we can combine this possibility and we can configure a system where air is used first for an oven, then in series goes to a dryer when it has less temperature. Another interesting feature of this concept is that hot air can be sent to a packet bed system where heat is stored, heating the packet bed when we have solar energy, and then releasing heat maybe during evening or during night, so for cooking food when solar energy is not available. So this concept can be implemented maybe using a commercial collector. For example, a 26 square meter concentrating collector can provide 15 kilowatts of thermal power. And we already demonstrated that this system can produce hot air up to 150 up to 400 degrees. So a temperature which is very good for cooking and for different applications. So we can say that this configuration using a linear Fresnel with hot air gives a wide range of potential application. So in the next studies, we will analyze and consider all of them. The advantage is to use air as heat transfer fluid, so configuring an indirect solar cooker, and we use commercial component, commercial reflector like linear Fresnelcollector, which are mature technology and potentially low-cost technology. Thank you for your attention.